Hey guys, it's Friday, March 20th, and we're just going to do another quick rehash of Coulomb's law. So this is the way that we can actually measure how much force of attraction there is between oppositely charged things, or how much force of repulsion there is between two like-charged things. So our formula is the force between them equals K, which is just a constant. It's always the same number. It's not going to be important what that is for right now. Times the product of the charges. Remember, Q represents the charges of the either object, the first object and the second object, divided by the distance between them squared. Okay, so remember, the easiest thing to think about is if we know how much force there is to start, then if we're just going to change maybe the charge of both of our objects, or we're going to change the distance between them, the easiest thing to do is kind of imagine they were all ones to start with, right? So we're going to have our original, being 1 equals 1 times 1 times 1 divided by 1 squared, right? So then we can kind of see the effects of doubling one of the charges, or doubling the distance, or having one of the charges by just plugging in 2's if they double, or 0.5 if they're halved, etc. And this should be the third page of the stuff that I sent home to you. It says Coulomb's law. We're going to walk through their first example here. It says two charged particles, Q1 and Q2, are at a distance d apart. An electrostatic force F exists between the particles. The final distance is 4 times the original distance. So 4d would mean it's 4 times what it was originally, right? So I'm going to say, here's my new setup. Okay, so my new setup, I'm trying to figure out what the force is. Okay, I didn't hear anything about the constant changing, so that's still going to be 1. Didn't hear anything about either of the charges changing, so they're both still going to be 1. But now the distance is 4 times greater. So where I had a 1 here for distance, I'm going to put a 4, but remember it is still squared. Okay, so if I calculate this, it would be 1 times 1 times 1, 1 on the top, 4 squared is 16. So this doesn't say my new force is the force is 1/16 newtons. It's 1/16 of the original force. Right? We don't know what the original force was, and we don't know what the new force is, but we know the new force would be 1/16 the size of the original force. One more thing I kind of want to drive home about Coulomb's law is the sign. Okay? So if we have two things and they have opposite charge, maybe this one's positive and this one's negative, and I was going to use this formula, I'm going to calculate the force equals K. Again, for the purposes of this, let's not worry what K is. If this one, we'll even make the math really easy. We'll make it positive 1 and negative 1. Okay, so this is positive 1 times negative 1 for our charges. And then again, distance can't be negative, so we'll just make that. Is this going to be a positive value or a negative value of force here? Okay, so we have some number times a positive number times a negative number. Is that going to be positive or negative? Hopefully you realize that's going to be negative. Okay, and so we would calculate a negative force, and I have opposite charges. So we know a negative force must mean what then? Attraction or repulsive. So a negative force, opposite charges must be attractive. Okay, but if we flip it, okay, I'm going to separate this out here. If we flip it and we have two negatively charged things, okay, so same idea. Now I would have negative 1 times negative 1. A negative times a negative would give us a positive force. So we know like charges repel. So a positive force in Coulomb's law must mean repulsive. Right? They're pushing away from each other with that force. And let's just go through the last final possibility here. Maybe they're both positive. Okay, so we would have positive 1 and positive 1. And again, so a positive times a positive is also a positive. So that just kind of agrees with what we just said, right? So if we calculate, if they have opposite charges, we're going to calculate a negative force. So anytime we calculate a negative force, when Coulomb's law is what we're using, it's attractive. If we end up with a positive force, it is always going to be repulsive. They're pushing each other apart. So kind of like yesterday, what I'd really like you to do, and this probably won't take you very long, is the math practice here on the bottom of the page that looks like this at the top. And just like we did on the last one, I've had a couple people do it again or already, is just do that and take a picture, and you can either turn it in here on Google Classroom or you can email it to me. But it's just these three. Please write out kind of your setup and then answer just like we did on my example one where I said like 1/16 of the original force, or maybe it's 4 times the original force or double the original force, whatever it happens to be. But I would just like you to try these 3 problems, and that will be your assignment for today. Let me know if you have any questions. Bye.